Routers use dynamic routing protocols and preconfigure static routes to deliver packets using the best route possible between two subnets. Static routes are used on simple network implementations where manually configure a route is not an administrative burden. Static routing is limited for the following reason. It requires manual creation and management. It should not be used on networks with more than 10 subnets. And all affected routers require reconfiguration if the network changes. As network grows in size, it becomes more difficult to manually configure routes. This is when dynamic routing protocols can be helpful. Unlike static routes, dynamic protocols route traffic based on information they discover about the remote network from other routers. Remember that we talked earlier in the lesson that in Windows Server 2008 you can configure the RIP version 2, and the OSFP. In Windows Server 2008, the one that we use the most is the RIP version 2. Remember that RIP version 2 uses partner routers or RIP neighbors. This one to help him determining the dynamic routes it can use for forwarding packets of data. As routes are added to the RIP-enabled routers, neighbors will share the information about remote network. But remember that the downside on the RIP is that it always will broadcast to every router in the network. The one that it does with a specific router is the OSFP. For those environments in which static routes are insufficient, Windows Server 2008 includes the following three routing protocols that can be added to the routing and remote access service. First one that we have mentioned before, the RIP version 2 or Router Information Protocol version 2. As described previously, this protocol is designed for exchanging routing information within a small to medium-sized network. It enables routers to determine the appropriate path along which to send traffic. Then we have the IGMP router and proxy that is used for multicast forwarding. And then we have the DHCP relay agent, also considered a routing protocol in routing and remote access. This service relays DHCP information between DHCP server to provide an IP configuration to computers on different subnets. Most networks you work on probably have modern network routers. Most of this supports the passing of DHCP broadcast messages between subnets without a DHCP server to subnets that contains a DHCP server. These routers are known as RFC 1542 compliant routers. In situations where you don't have this kind of routers, you can create a DHCP relay agent using ROS. I would recommend you, if you don't remember what is a DHCP relay agent and the functionality, to go back to lesson 4, the second part of lesson 4, that I will explain that in detail. I hope that you guys remember actually. A DHCP relay agent manages the communication between a network DHCP server and clients on subnets without a DHCP server. With RAS, network adapters are added and configured to listen for DHCP broadcast messages. When a broadcast message is received, the communication will be forwarded to the DHCP server on the network. Routing and remote access also includes support for demand dial routing, also known as the dial-on-demand routing. When the router receives a packet, the router can use demand dial routing to initiate a connection to a remote site. The connection becomes active only when data is sent to the remote site. The link is disconnected when no data has been sent over the link for a specific amount of time. Because the DL on-demand routing connections for low traffic situation can use the existing DL app telephone lines instead of the leased lines, demand DL app routing can significantly reduce connection cost. The first step in deploying the demand DL routing is to configure a demand DL interface on each computer you wish to function as a demand DL router. You can configure this interface by using the demand DL interface wizard when you initially set up the routing and remote access, or as an option after the RAS service has already been configured and enabled, you can use the wizard as well. If you have previously configured and enabled the RAS service without demand DLL functionality, you must enable this functionality before you create any demand DL interface. To enable this interface and this functionality, you must select the LAN and demand DL routing option in the General tab of the Routing and Remote Access Property dialog box. Check this mark and then just click Apply. A Windows Server 2008 computer that runs the Routing and Remote Access Server role can provide a number of different types of remote access connectivity for your network clients. These include remote access for clients, either using dial-up or VPN access. The RAS service also allows you to configure a Windows Server 2008 computer to act as a network address translation device, which allows internal network clients to connect to the Internet using a single shared IP address. You can configure a Server 2008 to function solely as a NAT device or else to provide both NATs and VPN services simultaneously. Also, you can configure a Windows Server 2008 computer to create a secure site-to-site connection between two private networks, such as two branch offices that need to connect securely to one another over a public network such as the Internet. When configuring the routing and remote access server role, you can provide connectivity for remote access clients using one of the following technologies. As I said before, the DLAP networking or the virtual private network access. The DLAP networking creates a physical connection between a client and a remote access server using a dedicated device such as an analog or an ISDN modem. An example of a DLAP networking is a laptop that has a modem installed, which the clients use to dial the phone number of a remote access server. Once the modem creates a dedicated connection to the server, the remote access server allows the caller to access resources within the corporate network. Since DLAP networking uses a dedicated physical connection, DLAP networking connections often use the unencrypted traffic. And then on the other hand, we have the Virtual Private Network, or VPN. This connectivity creates a secure point-to-point connection across either a private network or a public network such as the Internet. VPN relies on secure TCP/IP-based protocol called tunneling protocols. This is to create a secure VPN connection. The remote access server authenticates the VPN client and creates a secure connection between the VPN client and the internal corporate network that is tunneled over the public Internet connection. In contrast to DLAP networking, a VPN is a logical connection between the VPN client and the VPN server over a public network like the Internet. In order to secure any data sent over the public network, VPN data must be encrypted. There are several options available to you when configuring remote access. First, remote access with DLAP or VPN. This option enables remote clients to connect to the server by using either a DLAP connection or a secure VPN. Second, the network address translation, or NAT. This option enables internal client to connect to the internet using a single external IP address. Third, we have the Virtual Private Network Access and NAT. This option configures NAT for the internal network and configures VPN connections. Then we have the secure connection between two private networks. This option is useful when, for example, setting up a router-to-router VPN. Actually, that one is a pretty cool one. And finally, we have the custom configuration. You use this option when none of the service combination meet your exact need. That's why it's called custom configuration.